Query Optimization Basics. By now you know all of the SQL that you need to know in order to pass your SQL Fundamentals 1 exam. Therefore, consider this final nugget of the series sort of a capstone. What we're going to learn here are some best practices for optimizing your SQL for fastest performance. Now, the basics term in my nugget title is well chosen here. As I've mentioned earlier in the course, the subject of optimization and performance tuning is an entirely large subject that could very well warrant its own nugget series. So we're going to focus on the basics in this nugget. First, by investigating how Oracle parses queries. We'll then look at and learn how to view execution plans and see exactly how Oracle is breaking out and satisfying the results of the query. And then finally, as mentioned, we're going to give some best practice advice on how to optimize your SQL, which in some cases involves you as the DBA getting into the driver's seat and tweaking how Oracle execution plans work. Let's get started. So how does Oracle parse a query? First of all, what does the word parse mean? Parse is a verb that means analyze or interpret. And the first thing to know, and a lot of this, some of this anyway, I'm not going to say a lot of it, bleeds over into the DBA1 skill set. In particular, this first step, the fact that when a user submits a query to Oracle database, the query itself is stored in an area of memory on the Oracle server called the shared pool. Now, the shared pool is just one memory pool of many in the Oracle construct called the System Global Area, or SGA. As I said, I'm not going to talk about the SGA too much more at this point. Check out the DBA1 training for a full breakdown of what this is, but consider the shared pool our work area for parsing the query coming from the user. You also should understand that Oracle Query Optimizer will hash the SQL and store it in that shared pool for faster reuse. Now, what does this mean? Well, a hashing algorithm takes a variable length input and then through the magic of mathematics converts it into a fixed length output. Now, the idea with hashing algorithms is that they're not reversible. It should be theoretically impossible to reverse engineer what's called a digest back into its original value. But what's nice about the hash value is that because it's more compact than the original variable length input, we can create these unique digest values of each query coming into the shared pool, and then subsequent runs of that query. If user A submits a query that goes into the shared pool and is hashed, 10 minutes later user B happens to submit the same query to Oracle. Oracle can compare the hash values instead of having to do a full hard parse and check all of the syntax of the original statement to ask itself, was this statement already parsed by some other session? I'm getting a little bit ahead of myself, but this hashing algorithm improves efficiency big time in terms of Oracle's decision on what kind of parse it's going to do. All right, so what happens after the query comes into the shared pool and it's hashed is Oracle performs a number of checks and analyses on that SQL. First, we have a syntax check, which is where Oracle is going to just literally look character by character and make sure that your SQL is intelligible. If you've forgotten a keyword, maybe you're running a select and you forget the from statement, then the query will fail and error out at that point. If you forget a statement terminator, a semicolon, again, basic stuff that can trip up even experienced DBAs if they're working too quickly. Once the SQL passes muster syntactically, we move to a semantic analysis, and this deals with things like name resolution. Can Oracle locate the tables, views, other objects that are indicated in the user's SQL query? Do the column names actually exist in those tables? Can Oracle understand the way joins are constructed by the user? Also in the semantic analysis is security checking, authentication and authorization. Does a user have privilege to execute this query and access the underlying tables and views? Is what the user is trying to do allowed in the table or view? Maybe the user is attempting an update or an insert and has invalid values based on column constraints. That could be captured at the syntax check check level as well. Now, if you're thinking to yourself, well, Oracle is doing quite a bit of work here, that's absolutely true, and we haven't even gotten to the point of creating an execution plan, which is going to be a cost-based algorithm to develop a path, an access path, to satisfy the query as quickly as possible. So we're dealing with quite a bit of input-output, or I/O, when Oracle parses or interprets a query from a user. So after the syntax check and the semantic analysis, Oracle, as I said earlier, looks at the hashing value of queries that are in the shared pool compared to the new hash value of its current query that it's looking at. And Oracle asks, is there a match or not? And depending upon whether the answer is yes or no, the rest of the parse will either be of the hard or soft variety. Now, a hard parse means that Oracle has to compute its cost-based execution plan from scratch. Now, cost means that some access paths are more efficient than others. We talked about earlier when we learned how to use indexes that the highest cost way to satisfy a query is to run what's called a table scan, where row by row, column by column, Oracle is going through the raw data in a table to fetch the appropriate rows. Now, if we're doing a select splat, a table scan may actually have the lowest cost as opposed to looking through indexes and then getting down into the leaf level of those indexes only to find reference IDs to go back to the table to find the rows that it could have just as efficiently or even more efficiently retrieved by using a table scan. So in most cases though, especially when we're using where clauses and joins, we'll want to make use of one or more indexes and perform an index seek, which obviously is a much lower cost algorithm than doing table scans in most cases. Again, we're talking about I/O here. Input, output in all four of the major subsystems on a computer. We're talking about disk I/O because we have to access data files and pull data blocks from those data files, read blocks from the data files, etc. Network I/O because we're receiving queries from the user and sending the results back over the wire back to that user. Memory, as we mentioned, the system global area that's part of the Oracle instance, and the program global area, or PGA, components that are part of the user session all consume RAM memory on the server, and your shared pool is a working set in RAM, so obviously that's going to be affected. And then finally, we have processor power that's being invested here. The more of this work the Oracle server does, obviously the more it cranks up CPU utilization. So what's the difference between a hard parse, which we just defined, and a soft parse, which is what happens if Oracle determines that the current query under consideration has a matching hash value to a query that was previously satisfied and exists in the shared pool? Well, that's a soft parse, and that's going to be strongly preferred because obviously Oracle has already done the heavy lifting and already has its best execution plans stored, so we can just go with that. It makes sense, doesn't it? Now, there's mitigating factors here that we're going to look at in the next couple of whiteboards. It's not always as easy as that. I'd mentioned earlier that you want to avoid ad hoc queries wherever possible. We want to pipeline our queries so that the same exact SQL, or at least as closely as humanly possible, those queries get submitted through your line of business application to facilitate soft parses. One commonly used mechanism for ensuring consistency in your SQL is to use what are called bind variables. Now, I want to say right at the outset that bind variables are similar to the substitution variables that we looked at earlier in the course and that are used in place of literals. So in a sense, they're the same basic idea. The big difference between bind variables and the substitution variables we learned earlier in the course is that those substitution variables don't have any effect on the SQL execution. In other words, the substitution variable technique that we learned earlier is actually part of the client software, the SQL Plus client, and the substitution happens on the client side, and then the finished query goes to the server, which really, those finished queries, if 3 users happen to run through SQL Plus the substitution variable method to run these 3 statements, then that would require 3 separate hard parses, because as far as the Oracle server is concerned, it's seeing these as static, completely non-dynamic SQL queries, where we're selecting some columns from the customer table where ID equals such and so. You see what I mean? So although these queries are almost identical, the only thing that's different is the where filter. We can make use of bind variables, specifically specifically in our PLSQL procedures, which is by far the way you want to do this in a business situation with a line of business application, is that you could use them similar to how we're doing here in the second example, where the query looks exactly the same as the three up here, but we're using a bind variable. And we can declare bind variables in our code, or we can just invoke them implicitly at use, which you see here. And the way that works is you use a colon and then the bind variable name. The benefit of this is the user runs the query and is prompted for a customer number in this case. And because the actual query, the bind variable, happens on the server, the stored query, hash value, etc., is going to be based on the variable name and not the value. So Oracle will use soft parsing much more often with bind variables than if you were not using bind variables. As a matter of fact, just by way of best practice, when you use PLSQL and define variables, those are automagically, to use a term an old colleague of mine used to say, instantiated as bind variables. Oracle is particularly good, not only, as I mentioned in the previous couple nuggets, the fact that we have this advisory framework, including an SQL execution plan advisor, where Oracle can analyze our representative SQL and give us tips on how we can help Oracle form the best execution plans. But Oracle also leaves nothing to our imagination. It's not a black box system. We can, through SQL, use the explain plan statement, or using, say, SQL Developer, we can do this graphically, and ask Oracle to reveal to us its access path in satisfying a query. Again, nothing is left to the imagination. When we interpret the results of an execution plan, it does take some finesse and skill to do that, no question. The three main aspects we're looking at are, number one, to do what we can to eliminate table scans, obviously, and the other big thing that comes into play with execution plans occurs when you're querying across join tables. We want to make sure that Oracle is choosing the best table join method and that it's using the optimal table joining order. So in one way, newcomers may want to just rely upon Oracle's execution plan, saying, well, Oracle knows better than I do as far as how to satisfy this query. But in the name of performance tuning, we don't want to just give Oracle too much power there. We want to step in sometimes and just make sure that Oracle's doing its job, and sometimes it's not, quite honestly. Sometimes Oracle's access path, we'll discover, is not optimal. So we can modify the execution plan in a couple different ways. One common way is to use what are called Query Optimizer hints, or hinting. Now, the word hint is a suggestion. So what we're doing here is at query execution, we're telling Oracle in advance things like use this particular index, use this particular join order, etc. And how you use optimizer hints, it's kind of an interesting syntax. You'll recall that comments in SQL can take the form of double dash for single line comments, or we can use the C-style commenting where we use /* to open up a multi-line comment and then */ to close it. And that's how we use hints. Right at the beginning of our query, as you see here in our sample code, I'm inserting a query hint, and besides the comment syntax, you notice we have the plus operator. This is just how Oracle handles hinting. And then we can pass in a comma-separated list of one or more hints that customize how Oracle will compute its execution plan. Now, the index keyword enables us to suggest a specific index. So in this simple example, we're selecting 1, 2, 3, 4 columns from the employee table where emp ID is 1007, and we're forcing Oracle to use the emp IDX index. That's really all there is to it. The toughest part is just to learn the syntax, some of the keywords and ways that we can customize the execution plan. You don't need to know the subject to that degree of depth to pass your SQL fundamentals test, so don't worry about that. Final subject before we do our brief demo, our final demo of the course, are some general tips on optimizing our SQL queries. This is a really nice graphic that comes to us courtesy of, as I've shown you before, one of my favorite Oracle-oriented websites, dbaoracle.com. And the way those folks have stacked their suggestions are from the most granular level at the SQL statement level, and then we have instance level or server level tuning, and then in the hardware, the Oracle Server hardware, how to tune it for optimized SQL. We're not going to look at every one of these options because it goes far beyond our scope for this course, but I'm going to draw out a couple that I think are the most salient points. Let's start down at the bottom here at the SQL statement. We've learned how hints work. Hints force changes to execution plans. The thing with hints that's cool is that it gives us control over how the execution plan works. The downside to hints is that they're not stored for reuse. I mean, they are in terms of the shared pool, but the shared pool works on a circular algorithm just like any memory pool does. So if a stored execution plan hasn't been used in a while and Oracle needs to recycle that space, well, that old plan goes up the flue. We have a technology in Oracle called the SQL profile, where you can actually store a persistent execution plan that you believe is better than what Oracle comes up with, and Oracle will use the profile preferentially to run that. Take-home message here for SQL statement tuning: we have the ability to customize how Oracle does its execution plan, so it involves us as DBAs getting into the driver's seat. The other thing to consider is to rewrite your SQL for faster syntax format. Be consistent in your code, in other words. Moving up to the instance level, the point I want to bring out here is the importance of optimizer statistics. Again, we learn how to do this step by step in the DBA1 course. Bottom line is, it's up to you as a DBA to periodically instruct Oracle to refresh its statistics. Now, optimizer statistics refers to the informational grist for the mill, as it were, that the query optimizer needs when it satisfies our queries. This is metadata. This is making sure that Oracle has up-to-date info regarding your schema objects. What tables are out there, what columns are in those tables, constraints on those columns, joins, table relationships, all of that kind of stuff. Those statistics can get stale if you're not either in an automated fashion through, say, an Oracle job, or manually refreshing those statistics. A truism here with SQL performance optimization is that the query optimizer in Oracle is only going to be as efficient as the currency of its optimizer statistics. Finally, at the top level, at the Oracle hardware level, we have our four subsystems: disk, memory, CPU, and I will add network here. And the idea here again is scaling up and scaling out. Scaling up means adding more horsepower to our Oracle server. Hopefully it makes sense that the faster the disks, the more disk space we have to use, the faster and more RAM we have, the faster and more CPU power we have, the more efficiently Oracle is going to be able to work. In particular, the more RAM and disk space, particularly RAM space, we can size our shared pool and make it larger and just give it more, it being the Oracle server, of course, give it more working space to handle concurrent SQL queries from multiple users. In this, the final demo of our course, we'll look at SQL optimization in Oracle Database 11g. In our Nugget 20 demo SQL script file, I'm logged into the database as the HR user, and we'll start by looking at bind variables. Remember that the syntax for these upon declaration is colon and then the variable name. You can declare the variables in your SQL editor, SQL Plus, your script files, or in your PL/SQL code as you wish, but when you issue a bind variable in a query, in an ad hoc query, again, the parser, Oracle parser, knows that it is a bind variable because of the colon prefixing the name. So on line 4, we're selecting all from employees, where the employee ID is the bind variable, and typing is happening behind the scenes. Because this is a valid column in the employees table, Oracle is going to expect the data type that's bound to that column, which I happen to know is numeric. So we'll select those rows, and we're either interactively, if we're at a command line, asked to provide the value of employee ID, or if we're in SQL Developer, we have a modal Oracle dialog box and enter binds box where we can pass in a specific value just by typing it. 110, let's say. If we need to pass in null, we can do that. Click apply, and then the query goes through. As stated, when you're using PLSQL, your variables are considered bind variables by default. So on this line 7, I'm creating a procedure called salBump that takes one argument called empID. It's an input argument and it's formatted with the number data type. The query itself updates the employee table and sets the salary to double its existing value where the employee ID is that input argument. We then issue an explicit commit to make that update permanent and then end the procedure. Let's select these lines now. Procedure salBump compiled, and as you know, we can use the execute statement to invoke a procedure. I'm going to pass in our employee ID 110. Just for grins, let me rerun this earlier query so we can examine what employee 110's numbers are before we run it against the stored procedure. It looks like John Chen, his salary is $8,200. If we run the salBump procedure, passing in John Chen's employee ID, and then rerun that query, we see sure enough John Chen's salary is now doubled, so it works just fine. Moving on to execution plans, we can invoke an execution plan by using explain plan for before our statement. And I'm going to show you first how to do this in SQL as you see in these examples, and then I'm going to show you some of these buttons on the SQL Developer toolbar that are really quite nice. We can use explain plan for and then the query, or we can select the query and use the SQL Developer tool. Let's see, here it is right here, explain plan. Give that a click. I like the SQL Developer tool because it gives us a nice idea of what's going on graphically. Instead of when you're in SQL Plus and you use explain plan for, you just get a tabular result that in my experience is a little bit more difficult to understand. So what's going on here? Let's try to interpret this. The graphical execution plan says that it's looking at a select statement, obviously. We can expand this and see that Oracle, in satisfying this query, now this is going to pull back every row in the table. It's just going to pull back the value for last name. That should lead you to be thinking along the lines that we're not going to be doing a seek, but a scan. And the question is, are we going to do a table scan or an index scan? Well, Oracle here, it looks like, is using the emp name IX index and performing a scan of that index at a cost of 1. You may want to run tests and see if you could add a hint to do a table scan instead of an index scan. It's up to you on how you've got things going. That's the whole benefit of the execution plan environment. When you're in SQL Plus, you can also attach a name to a explain plan operation by using set statement ID and then a unique ID for that execution plan and then for in the query. I'm going to select this, a little bit more complex of a query that involves the like keyword, pattern matching. We'll click explain plan again and see what's happening. It looks like in this case we are in fact running a full table scan to look row by row for any employees whose phone number has a pattern match of 650. We might want to consider indexing on that column if it's frequently accessed. Let's look at again, explain plan. I'll just select the query. In this case, we are hitting up an index and it's performing what's called a range scan to jump down to our predicates. Remember, our predicate deals with our row filtering. So what's happening here is that Oracle is attempting to gather all employees, at least the last name column values, from the employees table where the last name begins with PE. Here's a more complex example here that I've pulled from the Oracle documentation. This grabs last name and hire date from two tables, the employees table and the job history table. That involves some and or Boolean logic as well, a little bit more complex. And because of that, we have some, within our select statement, lookups on tables as well as index lookups to satisfy those query results. To finish this demo, I'll show you another really gnarly example that I've found in the Oracle documentation. What this is showing is a fairly complex query that joins data from multiple tables, but what I want to draw your attention to is the fact that we're using a full range of query hints here. We don't need to discuss the deep meaning of each one of these. Basically, we're dealing with using a specific index and as well as specifying join orders and join types. We're kind of stepping into the driver's seat as previously discussed and making sure that Oracle builds an execution plan exactly according to our specifications. And we should find that our instructions are followed. There's our index lookup, for instance. Query Optimization Basics Review. We completed this nugget in a capstone fashion by truly applying all of the SQL skills we've learned over the course of this series to a real-world context. We understand now how the Oracle Query Optimizer works. We understand how query parsing happens. So we understand the decision that Oracle makes in terms of going the hard parse or the soft parse route and the advantages and disadvantages of each. We understand how to view execution plans and even modify those plans by using hints. And then we looked at best practice suggestions for optimizing SQL on various levels: the instance level, the hardware level, and the SQL statement level. So here we are at the end of the course, friends. I'd like to congratulate you on your hard work. You're now prepared to go in there and pass that SQL Fundamentals 1 test. And then if you haven't already done so, make sure to pick up the DBA 1 test so you can become an Oracle Certified Associate, or OCA. It's been a great journey. I've enjoyed being your instructor. I'm always here for you. If you have any questions, comments, concerns, curiosities, complaints, please feel free to contact me via email. My email address is timothy@nuggetlab.com. Final heads up, remember to visit nuggetlab.com, the website, to download the script files from this course. That should make it a little bit easier for you in terms of following along with me with the demonstrations. Well, I hope that this has been informative for you, and I'd like to thank you for viewing and thank you for working with me on this course. Best of luck to you in your career goals, and I'll catch you on the flip side.